Welcome back, folks. We've got another op-amp circuit for you. This one's fun. Let's do it. Okay. And here it is. Find I out. So again, I'm asking for that current. There is a current there. I'm trying to like drill into your heads that there's a current going in or out of that output. It doesn't get emphasized sometimes, and people tend to forget it. You're not going to forget it. You have a much better teacher than I did. Who taught me op amps? Oh, that's not true. I had a really good op amp teacher. All right. Label your non-reference nodes. Okay. Practice identifying nodes. I know I'm doing it here with you. I usually have people come to the board and do this. It takes some practice. Getting it wrong can screw up your analysis before you even begin it. Okay, label your current directions for your passive elements, and then let's make a plan. I see a voltage supply and I see an op amp. Okay, so I'm going to have 2 KVLs, and I have 4 unknowns, so I'm going to need 2 KCLs, and that's going to cover my 4 unknowns. Okay, the other thing that I notice, I wonder if you notice it too. Something about that voltage supply. Does that voltage supply connect to ground? It does not. Okay, it connects 2 non-reference nodes. So here's an op-amp problem. And just because I want to challenge you a little bit, I threw a supernode into it. Okay, supernode. Okay. So we got to deal with that supernode, but we know how to do that. It's the same. Okay, we're still using the assumptions about the op amp, but we know how to do analysis with a supernode, so we're going to be okay. All right, so let's write the KVL for the supernode. VB is connected to the positive side. VA is connected to the negative side, and that has to be equal to 4. My only gripe about the way that one's written is it's out of order. Okay, I would rather write it this way so that when I enter it in the system of equations, I don't screw it up. Okay, I'm going to squeeze in it's not the KCL, I'm writing the KVL for the op amp because this one's nice and familiar to us already from previous videos. These 2 voltages have to be the same, so it's going to be VC minus 0 is equal to 0, but come on, that's really just VC equals 0, and come on, and that's our second equation. We're halfway there. You know we got harder ones coming. Okay, 2 KCLs. I can't write it for anything attached to the voltage supply, but I can write it for the supernode, and that's one of the ones that I'm going to have to do. I can't write it for the node attached to the output of the op amp yet because I have too many unknowns. I don't want to introduce another unknown, so I'm going to write it for C. Okay, so we're going to have to write one for the supernode and one for C. Okay, so this is the KCL for the supernode. To my eye, it looks like this current, and this current are all leaving the supernode. So I'm going to have minus VA minus 0 over 6, minus VB minus 0 over 9, and then minus VB minus VC over 18. And that's equal to 0. Okay, that one looks pretty good to me. So we'll do our algebra on it. VA, what are we going to get? We're going to get 3/18. That's going to be 1/6 in front of VB, and plus 1/18 in front of VC, and that's equal to 0. So that's ready to go. All right. KCL for C. Well, there's really 3 terms, but one of them 0. So I'm really just accounting for these 2 currents. This one's going in. Here's KCL for C. VB minus VC over 18 minus VC minus VD over 72. I'm not doing that in my head. Maybe I could actually. I'm on like video 7 or 8 of today. Probably should do it in the calculator. Okay, 1/18 in front of VB, negative 1/18 and negative 1/72. Yeah, because that's 4. Yeah, okay. VC and plus 1/72 in front of VD equals 0. It's all behind me. Beep, beep, beep. There we go. Is that all of them? That was number 4. Let's enter them in a matrix and solve it and find what we want to find. So these two, I bet I can get them in my head. VA, I can just enter them right here. Negative 1, 1, 0, 0, 0, 0, 1, 0. Okay. Right hand side is 4 for that one, 0 for that one. Okay, so we took care of these two, right? This one's in the first row, this one's in the second row. Here we have negative 1/6, negative 1/6. Did it really end up being that? Yeah, it did. And 1/18 and 0, 0 on the right hand side. Last row I moved over to this equation here, and we have 1/18. We have this, which I'm being lazy and letting the calculator chew on, and I've got 1/72 out here. Okay, try to put some brackets around here so that you know that those two go together. Right hand side is also 0. Alright, solve that for VA, VB, VC, VD. And let's get some values. Okay. Calculator time. Follow along for fun with math. Okay, 0, 0, 1, 0, 0, negative 1/6, negative 1/6, 1/18, 0, 0, 0, 1/18, negative 1/18, minus 1/72, and 1/72. Cool. From that we get negative 2 volts, 2 volts, 0 volts, and negative 8 volts. Okay, I'm going to store those in my calculator. I encourage you to figure out how to do that. I haven't recorded the videos that I've already made you watch, so I'm hoping that in those videos I showed you how to do it. For all of the calculators that I can lay my hands on while I'm here at home. Okay, so we have our node voltages. We got to go find I out, and we're going to find that by writing the KCL here. Now we can do it, right? KCL for D, and I have this current coming in, so it's VC minus VD over 72, and I have IO also going in, and then I have VD minus 0 over 12 going out, and that's all equal to 0. Okay, so let's grab that, and I'll bring it down so that I can play with it. Oop. And we'll even clean it up a little. because you know me, I'm all about getting those style points. Okay, solve for I out. I don't even need to hear you groan and roll your eyes. I know it happened. Okay, so I out's going to stay on the left-hand side. I got to pull everything over to the other side. So it's going to be VD over 12 minus VC minus VD over 72. So get comfortable plugging that in, finding the solution however you need to. I'll take VD and I'll divide by 12. And if I take VC minus VD, divide by 72, then I'm going to take my previous answer and subtract from it. And I get negative 675.9 milliamps. Okay, that's an M. That's a lowercase m. I don't want you to confuse it with microamps, where it's a lowercase mu. Okay. It's the same. We're working with the assumptions. Okay. And there was a supernode, but we know how to handle that because we're just doing nodal analysis. That's all we're doing. Okay. There's your answer. And now, at the beginning of this series of videos, if I had put this in front of you, a lot of you would have quit. And that would have been a shame, okay? Because you already had the skills to do it. You just had to see it applied in this manner. So I'm hoping that right now you feel like you have the tools to go analyze any circuit with an op-amp in it. We're going to practice it. We're going to do some more in the live show. We're going to do some in web work. We're going to have fun with it. Don't worry. But we've got a new component. We know what to do with it. All right? So you can do nodal analysis now. I got to make you fast. So I'm going to show you the shortcut for nodal analysis. Stay tuned and good luck.